This presentation is going to feature imaginary numbers. What I'm going to do is I'm going to run through what imaginary numbers are and what they're used for. We're going to go through some of the rules, and then we're going to finish off with some of the powers of imaginary numbers. The reason why we have imaginary numbers is because this equation, x squared equals 9, has two solutions. X could be 3 and x could be -3. If you square any number, it could be a negative number, you will get a positive. However, what if x squared equals a negative number? There is no rational number that you can square that will give you a negative number like this. And this is where imaginary numbers come into play, because no real number would satisfy this. So when we have an equation or a question like this, we need to make use of imaginary numbers. Therefore, what we can say is, with an imaginary number, we can write the rule based on this, that x squared equals -1. For imaginary numbers, we can write an imaginary number which is denoted by an I squared equals -1. And by default, if an imaginary number squared equals -1, then another rule that you're going to need is minus the imaginary number squared will also be -1. Because remember, x squared, for when x is a real number, has two solutions. One positive, one negative. It's exactly the same principle here. So always remember these rules, because when you're dealing with imaginary numbers, this is as basic as it gets. And if you don't know this, you're going to struggle with everything else. One more thing before we go on to the powers. With imaginary numbers, as already stated, they're often denoted by an I. In some textbooks, and some students will write an imaginary number as the root -1. This is not correct, and I'll quickly go through why it's not correct. Because in maths we have the square root rules, where we have root a times by root b is the equivalent of root a times b. So we've all seen that rule before. In the situation where a is equal to -1 and b is equal to -1, and we apply this rule, we would end up with root -1 times -1, which will give us two negatives multiplied, give us root 1, which will just give us 1. But that's not right, because that should equal -1. Therefore, this is why this notation is a little bit misleading, and I was always taught not to denote an imaginary number as root -1. Use this notation to avoid confusion, as you've just seen in this situation, because it violates a basic rule of mathematics. Okay, so let's go through some of the rules for powers of imaginary numbers. And if you sit exams at the end of your year and you have a multi-choice aspect of that, this is very good to learn because it pops up all the time. So let's start off with the first ones, and this is going to be really easy because there's rules that apply to not just imaginary numbers but normal numbers. Anything raised to the power of 0 is 1. Anything raised to the power of 1 is just itself. That applies to any number. If you don't believe me, put it in a calculator, raise any number to the power of 0, it will give you 1. Same instance, any number, raise it to the power of 1, it will just be itself. So that's nice and easy. As we've already stated, an imaginary number squared will give you -1. The next thing we're going to do is we're going to start raising this to the power of 3, 4, and 5. And that is where things get a little bit more tricky because there's a lot of calculus involved, a lot more calculus than what we've just done here. So this is quite easy to remember. If you get this as a question, you should be able to just recall this from memory. So the first one we're going to start with is obviously an imaginary number raised to the power of 3. Now we already know, so we can, because we know that I to the power of 2 is equal to -1, what we can do is use that. Because we don't want to go calculating things that we don't have to. So basically, I to the power of 2, or I squared, is -1. So let's just put -1 in place of I squared. Anything multiplied by -1, you just change its sign. So there we go. And now we can build on from what we've already done to answer the next question. If we know that I to the power of 3 is -I, then we can just substitute that for -I because it's the equivalent. And let's put that in brackets. Multiply it by I, which will give us -I squared. What is -I squared equivalent to? It's equivalent to 1. And you can sort of get the hang of how you answer these questions now, can't you? So we substitute in what I to the power 4 is. Let's write it the longhand way, just while I'm teaching. And then we multiply that by I. 1 times I is just I. And it's as simple as that. A bit more calculus than the first examples, but you get the hang of it. Just do it this way, because if you can save yourself some multiplying and calculus, then you're going to make less errors. And if we finish up with I to the power of 6, then we can actually come up with a pattern. You'll notice a pattern. So let's carry on as we was. I to the power of 5 multiplied by I. So we know I to the power of 5 is just I. So that leaves us with I multiplied by I, which gives us I squared. What is I? We know by the rules, I squared is equal to -1. Now remember, if we go back over just quickly, and then I to the power of 2 equals -1. We can see a pattern here. We have 1, I, -1, -I. 1, I, -1. The next would be -I. So there is a pattern. If you do have a question on your exam, for instance, what is the 8th power? As long as you can remember this sequence, you don't actually need to do any calculating, because you can go on for as long as you want and this will always be the sequence. So that is a bit of a hack. Don't forget to subscribe, because we will be doing more imaginary number videos in the future.